For number 3, I would rewrite your function as the following. I rewrite as equals 1000 times 1 plus e 5 minus 0.2 t, that raised to negative 1 power. Try to avoid quotient rule if you could. I mean, it'd be fine, but I'm going to try to avoid it here and use a combination of power and chain rule. So now when I take the derivative of p of t, and we'll worry about plugging in 10 later. Let's just take the derivative first. You have your 1000, that's your constant multiple, times negative 1, because you got to bring the power down. 1 plus e 5 minus 0.2 t. Now it's going to be raised to negative 2 power. And then we got to take the derivative of the inside function. So you really want to be careful here. So I get negative 1000 times 1 plus e 5 minus 0.2 t to negative 2 power. Then we take the derivative of that. Derivative 1 is 0. And derivative exponential function is basically itself. But then we also have to use chain rule, which will just be negative 0.2. Let me clean that up here. Times negative 0.2, because the derivative of 5 minus 0.2 t is negative 0.2. So now when I clean it up, I should get 200 up top times e raised to the 5 minus 0.2 t power. And the bottom, I should have 1 plus e 5 minus 0.2 t with that whole thing being squared. See, now I can plug in 10. Now that'd be a smart idea. So it'd be 200 times e cubed, because remember 0.2 times 10 is 2, 5 minus 2 is 3. Down below, 1 plus e cubed squared. Be careful when you punch this in the calculator. You could try doing it all in one shot, or you could type in the numerator first, store it as a value like a in your calculator, then type it in the denominator, store it as b, and then do a divided by b, so that way you get a more accurate answer. Because if you try working each of these individually, and then approximating the decimals, then multiplying together, your answer might be off by 1 or 2 decimal places. So you really want to be careful about that. So if you work this out, you should get 9.035. So that concludes number 3.